The diagram shows a particle with linear momentum p, which is equal of course to its mass times its velocity vector, and the particle is located at point P in the xy plane. The angular momentum of this particle with respect to the origin O is defined as capital L, and that is equal to the cross product or vector product of the position vector r and the momentum vector p, which in turn is just equal to the mass of the particle times the cross product of the position vector and the velocity vector of the particle. As the particle moves relative to the origin O in the direction of its momentum vector, its position vector r rotates about O. Note that to have an angular momentum about O, the particle itself does not have to rotate around O. The direction of the angular momentum vector is perpendicular to the plane containing the position vector and the momentum vector, p, and its sense is determined by the right-hand rule. The magnitude of the angular momentum is just given by the mass times the magnitude of the position vector times the magnitude of the velocity vector times sine of the angle phi, where phi is the angle between the momentum vector and the position vector. This can instead be written as L equals r, the position vector, times p perpendicular, where p perpendicular is the component of the momentum vector perpendicular to the position vector r. Alternatively, we could say that L was equal to r perpendicular times p, where r perpendicular is the perpendicular distance between the origin and the extension of the momentum vector p.